Hello, am I audible? And is my screen visible? Can anyone please let me know?
Yes, yes.
Okay. Good evening, everyone. Welcome to this NPTEL live session for the course Deep Learning IIT Ropar. My name is Learning-IIT. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 7th live session, and we will discuss some practice problems on topics covered in week 7. So in week 7, bias, variance, trade-off, then train error, test error, and some regularization methods were discussed. So we will solve some questions on these topics, and if you have any questions or queries on any of these topics, you can ask me during this session. Okay, we will start solving the practice problems first. Then if you have any questions or doubts, you can ask me after that. So this is the first question. Which of the following is false? So there are three options. High variance leads to overfitting. That is the first option. Second option is bias is high if the hypothesis cannot model the true data distribution well. Option C is high variance leads to overfitting. High bias leads to overfitting. So you have to find which option is false among these three, and you can write your answer in the chat. Bandana Mahajan says option A. Sneha says option C. So you have to find the false option among these three. Anyone else? Correct answer is option C. So that is false. That high bias leads to overfitting. So high bias means there is more error in the data. More error in the predictions. So that means it is not overfitting. It is actually underfitting. So the model is very simple. That's why high bias is high. So in that case the model underfits, not overfit. So that's why option C is false. And for the other two options, so the first option says that high variance leads to overfitting, which is correct. So for overfitted models, the variance is high. So for very small changes, it changes the output, which we don't want. We want to generalize well so that it does not respond to noise and outlier points. So high variance leads to overfitting. And option B says that bias is high if the hypothesis cannot model the true data distribution well, which is also correct. That if the hypothesis cannot model the true data distribution well, that means the predictions of the hypothesis are very much different from the actual output of the data or the target variable. So bias is the difference between the prediction and the actual target value. So bias would be high in that case. So the false option is option C, which is high bias leads to overfitting. So the correct option would be high bias leads to underfitting. So that's why option C is the correct answer here. Is it understandable? Now question 2. A statement is given that increasing the number of hidden layers in a neural network reduces bias. So you have to state whether this statement is true or false. So statement is that increasing the number of hidden layers in a neural network reduces bias. Vandana says option A, Sneha also says option A. Anyone else? The correct answer is true, option A. So if we increase the number of hidden layers in a neural network, so the model becomes even more complex. So the complex model should have low bias, because we are increasing the complexity of the model, so it also increases the capacity of the model, so it can model the data much better, and it will generally reduce the bias of the model. So option A, true, is the correct answer here. Question 3. When would bagging work? So bagging is an ensemble algorithm. I hope all of you have gone through the lecture videos. When would bagging work? There are three options. If error of different models are perfectly correlated, if error of different models are not correlated, if error of different models are moderately correlated. Vandana says option A, Sneha says option C. Any other answers? The correct answer here is option B, that if the error of different models are not correlated or uncorrelated, then bagging works well. So bagging is an ensemble algorithm. So in bagging we create independent different models from the same dataset for the same task. So either we create train those different models on different subset of the data, or you use the same dataset to train those individual models, and then we aggregate the output of those different models to produce the final output for the whole ensemble model. So if the error or the output of different models are correlated, then bagging doesn't have any advantage. But if different models have different outputs, then the aggregation would work well. Because if the output or the error of different models are almost same, then bagging doesn't have any advantage. It doesn't create anything other than what the individual models are saying. But if the output or the error of different models are uncorrelated, so different models are producing different outputs, then the aggregation means much more than the individual models. So that's why option B is the correct answer, that if the error of different models are not correlated, then bagging works well. Now question 4. Consider two models, f1x is equal to w0 plus w1x and f2x equals w0 plus w1x plus w2x square. Which of these models has higher complexity? So there are three options, f1, f2 and insufficient information. Pilla Rohini says of F2, which is option B. Vandana says option B. Priyangshu says option B. Correct answer is option B, f2. So as you can see, the first model f1, it is just w0 plus w1 equals to x, so it's basically order of x, and f2 is w0 plus w1x plus w2x squared, so this is actually order of x squared, so the complexity of f2 is higher, so option B is the correct answer. Now question 5. Given the feed forward network below, how many thin networks can be formed from it using dropout? So thin networks are formed by using dropout technique. So we drop several units among the hidden layers, hidden units, in order to form those thin networks. So this is the network that is given, and if we only use dropouts in the hidden layers, so there are two hidden layers you can see, then how many thin networks can be formed from this feed forward network? So there are four options: 256, 128, 64 and 100. Rohini says 64. Okay. Vandana says option C, which is 64. So thin network basically means if we the network that neural network that results from dropout. So this is the original neural network, and if we use dropout in this network, then the resulting network is called thin network, because the number of units become lesser. So and in this case we are using dropout only in the hidden layer. So these are the two hidden layers. So in dropout what we do is that randomly we randomly or probabilistically we remove some of the units. For example, let's say in one thin network this is removed, this is removed, and this is removed. So these three hidden units are removed, these three. So this becomes a thin network. So these three are removed, and in another thin network, in one in the possibly in the next iteration, let's say this one and this one is only removed. So these two hidden units are removed. So this becomes a new thin network. So this is how dropout is used to create multiple different thin networks and then combine their outputs to form the final output. So this is also an ensemble method for neural networks. So from the same original neural network, some hidden units are removed using dropout. So we get several different thin networks, and then we combine their output to form the final output. So there are total 8 hidden units. We can see 4 in the first hidden layer and 4 in the second hidden layer. So we can remove any number of hidden units from these 8 hidden units in any thin network. So there are 8 total units, so 2 to the power 8 is the number of possible ways we can choose which units to be removed. So that is the correct answer, the 2 to the power 8, which is 256. So in any iteration we can choose any number of hidden units to be removed out of these 8 hidden units. It is so it should be like this: 8C0 plus 8C1 up to 8C8. Any number of hidden units can be dropped. So in that case it would be that is the, and that summation becomes 2 to the power 8, and that is 256. Priyanshu Raj says we can even remove all units. Yeah, removal of all units I don't think is possible. In that case it should be 2 to the power 8 minus 1 most probably. You are right that we cannot actually remove all the units. I forgot about that case. You can take all the units, but you cannot remove all the units in this case. So in that case it should be 2 to the power 8 minus 1. Yeah, most probably it should be it shouldn't happen that we remove all the units, then the input layer is disconnected to the output layer. Yeah, in that case it should be 255. Yeah, that is right. So 256 is most probably not the correct answer. I will update it in the slides that I will upload in the Excel sheet later on. So the technique is that you have to find out how many total units are there, and then try to find out in how many ways we can pick any number of hidden units to be removed from that. But certainly we cannot remove all the hidden units, so in that case minus 1 should also be there. So in that case 255 should be the correct answer, I think. Yeah, I will update these slides. So is there any doubt in this question? Now question 6. Which of the following is or are true for bias? So more than one option might be correct in this question. So complex models have low bias, simple models have low bias, complex models have high bias, simple models have high bias. So multiple options may be correct in this question. Priyanshu says AD, Dr. Ajita V says AD, Rohini says AD. Vandana also says AD. Is the correct answer, sir, A and D? So the complex models have low bias. So if the complexity of the model is high, then it can reduce the error in a much better way. So the bias would be low, but the variance might be high in case of complex models. And on the other hand, for simple models, they generally underfit. So in case of underfitting, we know that bias would be high, but variance would be low. So simple models have high bias. So A and D are the two correct answers. Question 7. Data augmentation works for, there are 4 options: object detection, image recognition, speech recognition, and option D is all of the above. Rohini says in complex models we have more parameters, we have less bias. Yeah, I mean in case of complex models, the we have more parameters, and its complexity is higher, so and its capacity is also better, so it reduces the bias error, but the variance becomes high for complex models. Vandana says option D, Rohini says option D. Priyanshu says option D. The correct answer is option D, all of the above. So data augmentation works for all 3 tasks here: object detection, image recognition, and speech recognition. So data augmentation basically is that you in case of images, you shift the image slightly, or rotate the image slightly, or flip the image horizontally or vertically if it is allowed for your specific task. So for object detection and image recognition, these are the kind of data augmentations. And in case of speech recognition, you can add a little bit of noise in the data, in the speech audio, or there also you can shift the audio timeline slightly, or clip the audio timeline slightly. So these are the different data augmentation techniques that can also be used in case of speech recognition, and these are such techniques are used for regularization in these tasks. So all 3 tasks, in all 3 tasks, data augmentation works well. Now question 8. In neural networks, bagging is computationally expensive in terms of training, testing, both training and testing, and none of the above. Rohini says option C. C is the correct answer here. For both training and testing, bagging in neural networks is computationally expensive. So if we generally bagging is not applied in neural networks because training neural network itself um, is a computationally expensive task only for one neural network. Now in bagging we have to train several neural networks independently or parallelly, and then we have to combine their outputs to produce the final output for the bagging. So all these independent neural networks have to be trained separately, and also that is so training it is expensive, and also for testing for the same input test data you have to run several neural networks and then combine their outputs to get the final output. So testing is also expensive in case of bagging in neural networks. So generally bagging is not applied in neural networks. Dropout works well for neural networks. It also creates an ensemble of neural networks, but much lesser computationally expensive. So option C is the correct answer. Now question 9. We are training a neural network with the following patience parameter equals 2. So we are using early stopping regularization technique with patience parameter equals to 2. When will the training stop? So we have this training error and validation error data for 6 epochs, and patience parameter is 2. We are using early stopping regularization. So if we use early stopping regularization mechanism with patience parameter equals 2, then when will the training stop in this case? So options are after epoch 5, epoch 4, epoch 6, epoch 3. Rohini says option D. Vandana says option B. So in early stopping regularization technique, we continue checking the validation error in every iteration. That way the validation error is decreasing or not in consecutive iterations. So we will observe that after in the second epoch the validation error decreases, and in the next epoch validation error again decreases, and the patient's parameter is 2. Basically means if the validation error doesn't decrease in 2 continuous epochs, then the training process is stopped. So up to epoch 3 validation error is decreasing. So after that we see that validation error doesn't decrease here, so it actually increases. So this is for one epoch that validation error hasn't decreased. Then again in the next iteration we see validation error doesn't decrease. So for 2 continuous epochs we have observed that the validation error didn't decrease, and our patient's parameter is 2. So we have reached the limit that for 2 continuous iterations, 2 consecutive iterations, the validation error didn't decrease. So in this epoch, after 5th epoch, the algorithm observed that validation error didn't decrease for 2 epochs. So after 5th epoch it will stop the training process. So 6th epoch will not take place anymore during training. Here it will not take place anymore. So the training will continue till the 5th epoch, and after that it will stop because of this patient's parameter, which is 2 here. So the correct answer will be option A, that after 5th epoch the training process will stop. So after the up to 3rd epoch the validation error was decreasing, but the training process will continue for 2 more epochs, and up to epoch 5, and then if it observes that still the validation error is not decreasing, then it would stop. So after 5th epoch it would stop, not that after 3rd epoch it should stop. Up to 3rd epoch the validation error was decreasing, but it will continue for 2 more epochs. If for 2 consecutive epochs the validation error doesn't decrease, then only it will stop. So the training will continue till the 5th epoch. So after 5th epoch the training will stop. So correct answer is option A. Option A is the correct answer. So validation error doesn't decrease in epoch 4 and epoch 5, hence the training stops after epoch 5 since the patient's parameter is 2. So is there any doubt in this question? So these were the questions that I wanted to discuss in this live session. And now if you have any other questions or queries, you can ask me.
Like I have a basic query. How do we know like what type of questions are these? Like when we go through the videos in early stopping, we were not told anything about the parameter.
No, patient's parameter P was talked about in the lectures, I think.
Yeah, patient's parameter was there, but then it was said that we have to do K minus P. So like K minus P, So this relation was totally different, like how we are the
No,
view,
so
how we are viewing the patient's parameter was very different in this question.
no, up
Uh,
to, for example, up to here the validation error was decreasing, so everything was fine.
yeah.
After that, for these two consecutive iterations, validation error didn't decrease. So that's why you will stop at this point.
Okay.
So this is what this question is about, that when you
Yeah.
stop the
So
process.
this gives a very practical view of patient's parameter, but in the video we didn't get this sort of
Yeah, in the video the theoretical part of it was taught, but the
yeah.
examples were
So
not.
how can we practice more such questions, like for exam?
How can you practice? It's difficult to say. If there are any
Yeah.
books recommended in the course page, then you can go through those
The
books with the
lectures
questions.
are in itself so extensive, but they are so much mathematical and theoretical that the practical aspect like this is not told.
Yeah, yeah, the video lectures are quite lengthy, but most of it is theoretical, because not much time is left in the video lectures for practical questions or numerical questions. So
Yeah, but in exam the questions will be like this, like practical application of those
the
concepts.
questions will be in the exams very similar to the assignment questions. So if you solve the assignment questions properly, you will get a lot of similar questions in the exams.
Okay. Okay, thank you.
Okay.
So we can leave.
Yes, yes. If there are no other questions or queries, then we can end this live session now.
Thank you.
Thank you. Thank you, everyone.